Alright, so in this problem I have 36 to the power of x minus 6 to the power of x is equal to 1260. So I'm going to first start by subtracting 1260 on both sides. So then these two cancel out, and I have 36 to the power of x minus 6 to the power of x minus 1260 is equal to 0. Now 36 is the same thing as 6 squared. So I have 6 squared to the power of x, and I can actually switch the places of these two. So this is the same thing as 6 to the power of x squared minus 6 to the power of x minus 1260 is equal to 0. Now I'm going to let 6 to the power of x equal to the variable y. So now I have y squared minus y minus 1260 is equal to 0. Now, I'm going to replace negative y with negative 36y plus 35y. And now y squared minus 36y is the same thing as y times y minus 36 plus 35 times y minus 6 is equal to 0. Sorry, 36 times y minus 36. And now if I factor out y minus 36, I get y minus 36 times y plus 35 is equal to 0. So this means that y minus 36 is equal to 0 and y plus 35 is equal to 0, meaning y equals 36 and y is also equal to negative 35. Now remember how we let 6 to the power of x equal y. So to start, we have 6 to the power of x is equal to 36, and we also have 6 to the power of x is equal to negative 35. So for 6 to the power of x equals 36, x is obviously equal to 2 because 6 squared is equal to 36. So this is one solution of x. Now 6 to the power of x equals negative 35. This will actually not work because you can't take the power of a positive number and make it negative. So my only solution is x equals 2. Now let's go ahead and check to see if this is right. So I have 36 to the power of x minus 6 to the power of x is equal to 1260. So I have 36 squared minus 6 squared is equal to 1260. And this is the same thing as 36 squared is equal to 1296 minus 36, which is equal to 1260, meaning 1260 is equal to 1260, and because this is right, our solution is right. Alright, so in this problem I have 2 to the power of x minus 2 to the power of y is equal to 120. So at first glance, we can already tell that 2 to the power of x is greater than 2 to the power of y, because 2 to the power of x minus 2 to the power of y is a positive number, meaning x is greater than y, because both of these have the same bases. So because we know that x is greater than y, we can say that x is equal to y plus some variable k. So now I'm going to replace x with y plus k. So now I have 2 to the power of y plus k minus 2 to the power of y is equal to 120. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of y plus k, that's going to equal 2 to the power of y times 2 to the power of k minus 2 to the power of y is equal to 120. Now if I factor out 2 to the power of y, I get 2 to the power of y times 2 to the power of k minus 1 is equal to 120. Now 120, this is the same thing as 8 times 15. And notice how we have an even number, 2 to the power of any number is even, times an odd number, because an even number minus 1 is going to be odd, is equal to an even number times an odd number, meaning these two even numbers are equal to each other and these two odd numbers are equal to each other. So we have 2 to the power of y is equal to 8, and 2 to the power of k minus 1 is equal to 15. So let's first start off by solving 2 to the power of y equals 8. Well, we obviously know that y is equal to 3, because 2 to the power of 3 is equal to 8. Now for 2 to the power of, this is actually 2 to the power of k minus 1. Negative 1 is not part of the exponent. So I'm going to start off by adding 1 on both sides. So I get 2 to the power of k is equal to 16, meaning k is equal to 4. Now, remember how we set x equals y plus k, and k is 4, y is 3, meaning x is 7. So now to check, my original equation was 2 to the power of x minus 2 to the power of y equals 120. So we know that x is 7 and y is 3. 2 to the power of 7 is 128, minus 2 to the power of 3 is 8. So I get 120 is equal to 120. Alright, so in this problem, I have x to the power of 6 is equal to x minus 1 to the power of 6. So I'm going to first start by subtracting x minus 1 to the power of 6 on both sides. So then these two cancel out, and now I have x to the power of 6 minus x minus 1 to the power of 6 is equal to 0. Now x to the power of 6 is the same thing as x to the power of 3 to the power of 2, and x minus 1 to the power of 6 is the same thing as x minus 1 to the power of 3 to the power of 2. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is going to equal x to the power of 3 plus x minus 1 to the power of 3 times x to the power of 3 minus x minus 1 to the power of 3, which is equal to 0. Now if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So this is going to equal k plus k minus 1 times k squared minus k times k minus 1 plus k minus 1 squared. Sorry, this is actually supposed to be x, but yeah. So this simplifies to 2x minus 1 times x squared minus x plus 1 times 3x squared minus 3x plus 1 is equal to 0. Because we also added in, remember, we also have x to the power of 3 plus x minus 1 to the power of 3. So now this gives me 3 different equations. I have 2x minus 1 is equal to 0, meaning x is equal to 1/2. I have x squared minus x plus 1 is equal to 0. And I have 3x squared minus 3x plus 1 is equal to 0. So for x squared minus x plus 1 equals 0, we have x is equal to 1 plus or minus the square root of 3i over 2. And finally, for this, we have 3 plus or minus the square root of 3i over 6. Alright, so in this problem, I have 9 to the power of x is equal to x to the power of 6. Now I'm going to find the value of x. So for my solution, start with 9 to the power of x is equal to x to the power of 6. And I'm actually going to take the power of 1 over x on both sides. So now I have 9 to the power of x to the power of 1 over x is equal to x to the power of 6 to the power of 1 over x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 9 to the power of x to the power of 1 over x, that's going to equal 9 to the power of x times 1 over x. And x to the power of 6 to the power of 1 over x, that's going to equal x to the power of 6 times 1 over x. Now x times 1 over x, these two cancel out, so it's just, I'm simply left with 9, is equal to 6 times 1 over x, which is 6 over x. Now I'm going to take the power of 1 over 6 on both sides. So now I have 9 to the power of 1 over 6 is equal to x to the power of 6 over x to the power of 1 over 6. And again, this is going to equal x to the power of 6 over x times 1 over 6. These two cancel out. So now I'm left with 9 to the power of 1 over x is equal to x to the power of 1 over x. Now, 9 is the same thing as 3 squared, so I get 3 squared to the power of 1 over 6 is equal to x to the power of 1 over x. 2 and 6, these make 3, so I get 3 to the power of 1/3 is equal to x to the power of 1 over x. And notice how this is in the form x to the power of 1 over x. A number to the power of 1 over that same number is equal to x to the power of 1 over x, meaning x is simply equal to 3. So now to check, my original equation was 9 to the power of x equals x to the power of 6. So I get 9 to the power of 3 is equal to 3 to the power of 6. And 9 is the same thing as 3 squared, so I get 3 squared to the power of 3 is equal to 3 to the power of 6, which is 3 to the power of 6 is equal to 3 to the power of 6. Alright, so in this problem, I have 49 to the power of x minus 42 to the power of x is equal to 36 to the power of x. So I'm going to first start by dividing every term by 49 to the power of x. So then these two cancel out, and now I get 1 minus 42 to the power of x over 49 to the power of x is equal to 36 to the power of x over 49 to the power of x. Now 42 over 49, that's the same thing as 6 over 7. And 36 over 49, that's the same thing as 6 over 7 squared to the power of x. And now I can actually switch the places of 2 and x. So this is the same thing as 6 over 7 to the power of x squared. Now I'm going to let 6 over 7 to the power of x equal to the variable y. So now I have 1 minus y is equal to y squared. And this is the same thing as y squared plus y minus 1 is equal to 0. Now, you have to use a quadratic formula to actually solve this, but if you do, you end up getting that y is equal to negative 1 plus or minus the square root of 5 over 2. And now remember how we let 6 over 7 to the power of x equal y. So now I have 6 over 7 to the power of x equal negative 1 plus the square root of 5 over 2. So let's first start with this. I'm going to take the log on both sides. So now I have log of 6 over 7 to the power of x is equal to log of negative 1 plus the square root of 5 over 2. So now I can move this x to the front and divide both sides by log 6 over 7. So now I have these two cancel out. X is equal to log of -1 plus the square root of 5 over 2 over log of 6 over 7. Now, we can also do the same thing with -1 minus the square root of 5, but it would just be the same outcome, but instead of plus, this is going to be minus. So I also have x is equal to log of -1 minus the square root of 5 over 2 over log 6 over 7. Alright, so in this problem, I have 99 to the power of x plus 9 is equal to 9,999 to the power of x plus 9. So to solve this, I'm going to first start by using the property of exponents that says a to the power of m plus n is equal to a to the power of m times a to the power of n. So by using this property, 99 to the power of x plus 9, that's going to equal 99 to the power of x times 99 to the power of 9. And 9,999 to the power of x plus 9, that's going to equal 9,999 to the power of x times 9,999 to the power of 9. Now I'm going to divide both sides by 99 to the power of 9 times 9,999 to the power of x. So then these two cancel out from my left-hand side, and these two cancel out from my right-hand side. So now I have 99 to the power of x over 9,999 to the power of x is equal to 9,999 to the power of 9 over 99 to the power of 9. Now this is the same thing as 99 over 9,999 to the power of x, which is equal to 9,999 over 99 to the power of 9. And now this simplifies to 1 over 101 to the power of x is equal to 101 to the power of 9. And this is the same thing as 101 to the power of negative x is equal to 101 to the power of 9, meaning that negative x is equal to 9 and x is equal to negative 9. So now to check, I have 99 to the power of x plus 9 is equal to 9,999 to the power of x plus 9. We know that x is negative 9, so now I have 99 to the power of 0 is equal to 9,999 to the power of 0. Anything to the power of 0 is 1, so I have 1 is equal to 1. And this is right, so I know my solution is right.